Welcome to our video on determining cable forces. Today, we'll be exploring the concepts of spring stiffness and length. Imagine you have a spring with a stiffness of 800 Nm. The length of this spring is 200 mm. The spring is attached to two supporting cables, each at a different angle. To determine the force in each supporting cable, we need to understand the physics behind it. The force exerted by a spring is directly proportional to its stiffness and the length it is compressed or stretched from its equilibrium position. Let's solve for the force in the first supporting cable. We'll start by calculating the amount of compression in the spring. To do this, we need to measure the elongation of the spring from its equilibrium position. By knowing the spring's length and the amount it is stretched, we can determine the compression. Now that we have the compression, we can use the formula for the force in a spring, which is F equals Kx. Here, F represents force, K represents stiffness, and X represents the compression. Plugging in the values, we have F equals. By solving this equation, we can determine the force in the first supporting cable. Now, let's move on to the second supporting cable. The process is similar to the first cable, but we need to take into account the different angle of attachment. Using trigonometry, we can determine the component of the force exerted by the spring in the direction of the second cable. By using this component, we can find the force in the second supporting cable. By applying these calculations to both supporting cables, we can determine the individual forces they each experience due to the spring's stiffness and length. Thank you for watching our video on determining cable forces. We hope you found it informative and helpful. Don't forget to subscribe to our channel for more interesting content.